Next example in 2.1 day 1 has to do with what we call vertex form of a quadratic equation. So I've got that vertex form written up here. You might want to get that written down because we're going to be referring to vertex form throughout this section, throughout 2.1 today and tomorrow. But we're going to start with the most basic form of a quadratic, which is considered to be in vertex form because it hasn't been modified at all. But we have the basic function y equals x squared. So when we're dealing with that, you could punch it in on your calculator. You'd find the vertex, the place where it starts, is at 0, 0. And so we're always working with that as a starting point for quadratic equations. The axis of symmetry is just the vertical line that goes through that vertex. So if I was looking at a graph that had my x squared graph on it, and I've got my vertex right here at 0, 0, then the axis of symmetry is just this line that goes down the middle of that. It's simply the x value of the vertex, but I do want you to include x equals. It is an equation of a line, so we have to have it in equation form there, and x equals 0 does it for this one. Now, taking this original graph, we can modify it using transformations, and then you'll notice this down here, this form represents vertex form, and we're just going to take a look at the transformations to decide what are going to be the vertex and the axis of symmetry in this case. So the transformations that produce this, first of all, when you have something inside the parentheses, remember we want to make it equal to 0. So that means that one transformation here, first one is going to the right by 4 units. And then the second transformation, the outside one, the -2, that's exactly as you would think it would be. That's just down 2. When you do that, it makes the vertex also go right 4 and down 2 from here. And so that's going to make, in this case, the vertex is going to be 4, -2. And much like the top one, when we're finding the axis of symmetry, you just take the x value and you say x equals that number, and so x equals 4 in this case. Another example, though it doesn't look quite the same as vertex form, you wouldn't necessarily think of this as being vertex form, but it is, because we could translate it into this, a times x minus h squared plus k. The only difference here is that the 7, for some reason, is moved out in front. So watch for that. If you want to, you can just scribble that out and rewrite that over here as plus 7, and that's totally fine to do. So now from before, from that previous example, just kind of the same thing. We get the vertex by going left 5, up 7. So in this case, the vertex is going to be -5, 7. And that means the axis of symmetry is just going to be x equals the x value, which is -5 in this case. Now, we do have some other transformations going on here. The other transformations in this problem have to do with a. So that's the -3 in this case. There are 2 more transformations. One of them is a reflection over the x-axis. That's the negative part. And then the other one, the 3, that is a vertical stretch by a factor of 3. Those, remember, can be in either order. That order doesn't matter there, but if we were putting all of this together, we would want to make sure we follow the order of operations to have the correct order of our transformations.